Hello, this is Professor Michael Abbasi, and I'm talking today about for Introduction to Computer Forensics, which is my CIS 2808 course, and we're looking at topic 5 at the time of this recording. This is with the EC Council content, and we're looking at defeating anti-forensics techniques. Very long-winded title. So what does that mean specifically? First off, here look at the objectives here. We're not going to, of course, delve into the entire chapter. You're expected as my student to review the chapter material and try and go and walk through the labs. But there's a couple things we'll highlight about uh, the topic itself here. And this one's FYI, make sure you check learning activities. There is actually a demo I have on my own YouTube channel here on Stay Guide, but there's also password cracking demo and think of our autopsy mismatching, and some other good reading material here for you to review. All right, so what we're looking at when we're talking about anti-forensics, what does the chapter really talk about? And all it really is someone's trying to make it difficult to find evidence. It could be, uh, someone has purposely tried to encrypt, password protect, hide a file, or they may have deleted evidence, but it has been deleted thoroughly. So if you watch any kind of 48 hours primetime live, found in the recycle bin, or we talk about that one a lot. Usually the people who are caught have stuff they deleted, then it's been just regularly deleted. And the empty recycle bin, for example, for Windows has been dumped, but files are not deleted. So, and why is that? Um, so first talk about deleting files. When a file is deleted, on most operating systems, the file itself is not securely deleted. Now, there's a secure deletion method, and you can get for Windows, Mac, Linux ways to securely delete a file, which will typically overwrite the file sector and the data parts of that file with zeros. Now it's a lengthy process. So for speed and to keep the computer running smoothly, the operating system assumes that when you want to delete a file, you just need to delete, but you don't need it no more. You're not trying to cover any kind of, your master plans to take over the world.doc. So what it does, it will basically just to remove the entry of the file. Same as going to the table of contents, and I want to remove a page from the table of contents. Maybe there's a few pages in the back of a chapter, maybe 3 or 4 pages. Well, instead of going back and ripping those pages out, or erasing those pages somehow, I delete it from the table of contents. So we'll come to that in a second here, but there are more than that. So we're going to look at really data deletion and password protection. Two of the main things that are used for forensics techniques. Stenography, last time I talked to the contact at the FBI's forensics lab, it's not really seen or used too much, and a couple other techniques. But actually, there was a news article not too long ago where someone actually tried using it. So again, these are different ways people try to hide evidence that's been deleted or just be hidden. So again, review the entire chapter material, but we're going to focus on a couple of key things here, and probably the biggest ones will be data deletion and some file mismatch, things like that. So again, when the file is deleted, normally, of course, normal deletion goes to recycle bin. So you always check there first. But it does go into, depends on the file system. For FAT file system, it's going to replace the first letters of the file name with a hex byte code, 5EH. Now, this is great because you can, if it's a FAT file system and you have some tools, and there's plenty of tools you're going to experience during the hands-on parts of the lab, and we'll look at one of them. But also, if it's using NTFS, which is probably more common, the bitmap itself is being marked in the bitmap. It's marked as free or unused. So the idea is you delete that page from the table of contents from the file location table, and if it gets the OS needs space, it will rewrite it later or parts of it later, where the data is at, and if the data clusters are within the file header or maybe they're outside of it. So as time goes by, there's more of a chance of it getting overwritten. or parts of the data being overwritten, which could become corrupted. But there are techniques to carve data out that have been deleted or just find files on a disk. Now, you can imagine scanning an entire drive, a 1 terabyte drive is going to take a lot of time if you do bit by bit, sector by sector, looking for all files. But there is a thing called file carving, and it's used a lot to extract all files from an evidence drive, for example. First off, let's talk about the old recycle bin. Pretty straightforward. What you need to look at here is here we are in Windows, and we are going to go ahead and we're at the C command prompt. And if you do a dir, normally you see just the basics here. So an important concept is dir with the switch of A, and that's going to show all files. And you can see here is recycle bin. And recycle bin is actually started with a $sign, and it's a .bin. So we see recycle bin on people's desktop, and that there's ways in the OS to sort of point to that. But we'll go and dive into this. We're going to cd into $R. I'm going to hit Tab key. It's going to help me not type as much. So again, and hit the up arrow, you can see previous commands. And here we see there's 2 entries. So there's one with the date time this recording. So maybe this is the date time we're interested in. Maybe this is what we think we need to look at. The most current deleted files, 2023. So I'm going to cd into this directory name here. That's a long name. So again, tip here, which you see I got from Linux, also works here in Windows, is s dash, and you can see it says 18. Let's go ahead and do backspace to 21 tab. Great, huh? So, of course, you can copy and paste. This is a command prompt. There's ways to copy what's been highlighted. So, and again, dir switch A, and we can see here is a file. So the key thing to come away from this is there's 2 types of entries. There's the $I and the $R, and these files are given this a random. I'm not sure where this comes from. This is there's some thing here. Looks like it's UZBBLK. Textbook should cover that. But the key thing here is just this: $I files are normally corrupted or damaged. $R are useful. So we can take this file right here and copy it back to our desktop. Now, of course, if you just go to the desktop itself, go to the recycle bin on the actual desktop of the computer here. Let's do that. You can just do this, and you'll see there it is. So anyways, that's all for that. That's want to show you where that takes place. And we'll go back to this here. So we'll come back to that in a second. So recycle bin forensics, take a look at that. For now, file carving. Now, what is file carving specifically? It's looking to recover fragments or fragments of files or all files. Even fragments could be valuable. You can imagine it's going to take more work to try to utilize a file fragment. But a key concept here, big takeaway here is this. There's something called a file header or a signature. This is also known as the magic number. So this is used in a few ways. Several tools will use this to carve out files and or look for file mismatches. So we're going to look at that here in a second. So for example, a JPEG file or as a GIF inside the file header has this actual hex code. Now these are hexadecimal, 4A, 46, 49, 46 here. And we'll look at a live example here of that. So maybe we have a file. Let's go to our other system. There we go. So here we have a file, to-do.txt. And maybe I'm interested in this file. Maybe it was discovered. So if I go to open it, let's open Notepad++. It looks like it's gibberish. So Notepad++ will open anything. It's a really great tool. Notepad actually might open a Notepad also. And let's try that out here. Let's just double click on it. Okay, Notepad actually opens it too. Sometimes you might get this. You'll find resume.doc, and you go to open it, and it wants to open Microsoft Word, and Word says files corrupted. So what we want to look at is this here. So this file is now open in WinHex. We can see right here, it says GIF right there. We have the file header of ffd8ffE0. So we can actually go to several locations, there's a place to find this, and we can do look up ffd8ff E0. You can see right down there. And you can see this is a JPEG file or JPG. So 4846, it goes by 001, and there's some indicators here for space holders. But 4A46 are the last few bits there. So this is not a text file. So you could simply go in here and we can just rename it. Let's just do this here, click on that. Okay, maybe right click. File properties. And right off the bat here, we can open it and now we see it is a JPEG file. So where does that come into play here? Has to do with file structures. And here's an example of a file structure. Now, every file has different structures. So there could be information inside here itself. We know, of course, the header. Now, of course, the /x is hexadecimals, ff, d8, d1, and so on. And we get the file size for the next, it's like the 0, 1, 2, 3, the 4th and 5th bit here. And then we have the EXIF header. Now, we, of course, you'll see later, EXIF data, fantastic, right? Metadata about a file. So even if the image data itself is corrupted, this is where a file parser could parse up to the start identifier frame, and you can write your custom file carvers, and maybe just get the EXIF data, and that's might be all you need. So maybe a location, EXIF, of course, for JPEGs could be camera model, location taken, date and time, and that metadata could be very handy as evidence, even if the image data itself has been overwritten several places, especially with large images. This image data is going to be on several different blocks of on the disk itself. So this is an example of what a JPEG file structure looks like. And now again, every different files have different structures. Um, Now, do we need to go in and actually use WinHex, which actually WinHex has some fantastic ways to carve out files built into it. But there are tools to do this, but I want you to understand how these tools work, what they're looking for. So file carving on Linux, there's ways to do it here. What I will show you is this. We have, so there is you can use something. Now I actually use an apt, I did an apt sudo apt install scalpel. But you can use something called Scalpel. So Scalpel itself is right here, and there's a demo for this linked in the shell. And actually, so I don't want to go over this, but Scalpel itself will carve files. Now, a key thing about this is you can either have a custom config file, that's just configuration file right here. If not, it will use the default scalpel.conf. And I want to show you this because if you just if you want to use Linux and you just point Scalpel at a disk image or whatever, and you try to carve it, and it comes up with nothing, there is some things that you look at, and we'll do this. I'll do a ls. It's an Etsy scalpel.conf. Now you could make a copy of this, but all it really is, and it gives you all examples here, but I'll show you. The idea is this: you don't want to carve for everything. A very large disk image could take a long time to carve. So you want to specify what you need. All you do is you go in with any kind of text editor like VI and you delete the comment sign here. So if I want GIFs or PNGs, let's actually do that here. Let's just do VI Etsy scalpel.com. So again, there's all information up here tells you about it, what it works, how it works. Got a really good header on there. So what we want to look for. We don't need AOL art files. Maybe we want JPEGs. So we'll go to as read-only file. Okay. Do this again. So that's a good hint here. Sudo vi for the lab. So make sure you sudo this file or become root. Now I can edit it. So, all right. So we want JPEGs. All you do is you just delete that right there. So I use X. I'm using VI. Use whatever text editor works for you. We don't want TIFFs. We don't want MPEGs. So you go through this and maybe you want to say, oh, I do want Word docs maybe. And you can see what it's looking for too. You see the header here. Again, search the /x with D0CF11E0. This is a .doc header. So it's actually a nice little sort of a database in a way. You can use this to look up, if you don't have access to the internet, you can use this to look up specific extensions and so on. So it looks good. So now I saved it, I can actually go on and carve my file with that. So again, and we can see the file signature here. So file carving Linux is great. There are also tools you can use for looking for deleted partitions, which is very possible. Someone will have a partition for their Word docs or their hidden documents, and that can be found there too. So another one of the main tools, though, you're going to use in this class probably, which is a fantastic tool, is going to be Autopsy. So now I've already loaded Autopsy and actually pointed at a few different data sources. I actually added data source to these, so I let it run for a little while. So just to let you know, it's one of the things you need to, when you add a data source, you choose what you want. Let's do that real quick here. You choose what plugins you want to use. So let's go ahead and add this Linux evidence SSD, and right here. Now you can imagine the more of these you check, these ingest modules, the longer it's going to take. Hash lookups, recent activity, but you want these three at least. If you want to look for carved files and a mismatch, extension mismatches, which is an easy way people try to hide stuff, and of course embedded file extractor, you want those three right there. Of course, you can add more. There's photo recovery tools and so on. I'm going to hit, gonna not actually bring that in. We're going to focus on what we have here. So you can see there's a results area, and it shows things like encryption detected, um, extension mismatch. Now this is also under the source, which I believe will be here. Let's see, Women's Evidence 001. Yeah, 001DD. So you can look at it here if you like, open files and so on. But this is a great way to show the extensions mismatch. So here we see this is a .trace extension. You can see the artifact ID. You can create a hash for this. But we can go to the text header. This is built right into Autopsy. Again, fantastic tool. So FFD8FF. So again, FFD8 to FF. We know there, or off the bat that this is a JPEG file. This is not a trace file. So forget with the rules that you follow for handling evidence. This, of course, this Windows Evidence DD image is a copy, a certified forensic copy of the original, which has been untouched. So it's fine. I can carve this. I can pull evidence out. So if I wanted to, I could extract this file. I could put it on my desktop. Now, of course, if I try to open it, .trace, but of course we saw that's a JPEG. So and now we can see it's the master plans for this, whatever it is. So anyways, so that's an example of Autopsy. Autopsy, we're gonna be in a lot. This is probably one of the primary tools I've used doing forensics work, for some email work and things like that. But this is a fantastic tool for carving evidence, and you can sort of see how that works. I also want to make sure we come down to is understand how carving works, whether you're using Scalpel or Foremost in Linux, or using an autopsy or any other tools. And the chapter goes over all the many tools you can use for finding deleted files, file carving. I don't want to go into all those here, make this an entire going for hours. But I want you to know how it works, understand what at its heart what it's doing, because you could write your own file parser. I wouldn't suggest that. Again, in the realm of keeping evidence um, worthy of course, being taken to trial. Um, all your tools have been certified, tested, things like that. There's records of those. So writing your own, maybe it could work, but it's also good to use a tool that has that built into it. So other things, of course, look at is passwords. Very, very common. Um, is and there's a lot of tools for cracking passwords, a lot of them. But there's some tools in this lab that are really great tools to use for cracking passwords uh, for files that have them. So here we see this is a sample1.doc. Now every file is going to be different. Zip files, PDF files, all keep their passwords sort of in a different part, and you can't just crack them open with a hex editor. Some old files you could, but it's hard to see anymore. So I've installed one of the lab things here, and this is the passware. And so I did this from the lab. You can see here's a sample1.doc. If I go to open it, it either says it's either corrupted or it's under rights management. So we'll assume it's under rights management and recover a file. So password desktop. There we go. So you can see it shows what it's going to use. Now there's something called brute force. Um, I'm sort of stickler about this one. Brute force is really algorithmic um, in the traditional sense. That means, for example, for brute force, try all A through Z lowercase for the first character, and then go back, and then do the same thing for the first, second, third, fourth, and then also maybe try um, 0 through 9, and of course special characters. And of course, this is really going to take a long time. The longer the password, the more complex. It's very hard to do. Uppercase A through Z, or try both, or mix match of both. Uppercase and lowercase, 0 through 9. So you can imagine the combinations of these. You can calculate them. 28 times 2, another 10. Special characters. You can see how this grows. And so what normally we do is it says brute force here, but you're actually using a dictionary file. So, or something called rainbow tables. And what we do is it has pre-computed possible passwords, and it creates a hash for those, and it uses that hash to try to get into the file itself. Oops. So use predefined settings, and you can see it's already started. Now, this is where the simplest passwords hopefully will be found first. Um, I've used tools like this, like Hydra, for example, or John the Ripper, or things like that to do hacking. Um, look at that. There's a ant. So there you go. So now it's ant. That's the password file is ant. That's the password that it found and was able to use it. So 12 seconds. So again, 3 characters, all lowercase. So you can see how 3 characters all lowercase. 1, 2, 3. A through Z. That's supposed to be an A through Z, A through Z, right? So very powerful, very simple. This could be a huge hit for the CPU though. There are password tools like Hashcat used for cracking passwords that can also utilize GPUs. I don't think we use Hashcat in the lab or John the Ripper, things like that, but Hashcat is probably the premier password cracking tool because you can use it to use GPU. And you can imagine you can utilize some very powerful GPU desktops that can increase the time it takes to crack things. So as for evidence, it's one of those things where if it's encrypted, and you think that that's it, this is the evidence file we need, then yeah, you throw everything you have at it. Otherwise, this could take a very long time. A very long password can take hours and hours, and it might type that entire system. So with the great resources, you could have then dedicate a password cracking desktop or workstation. Um, but just keep that in mind. So, but there are ways to do this. And that's one of them. So I just want to show you that. And there are other things in the lab I'm not showing you. There are ones where you look at zip files, PDFs. Um, so there are different tools for different app cracking. And the lab will walk you through this. Other places you can look for passwords. Of course, powered off machines. Um, we have BIOS passwords. There are it depends on the machine, depends on the BIOS. For example, I know like the Dell BIOS. There's tools to use to be able to slip in a recovery password. As long as you get to the BIOS screen or get the machine ID. Some manufacturers have the machine ID. You look it up, it'll have its own sort of pre-computed password, and you put that in, and then you do like Shift Enter or Alt Enter instead of clicking OK. And that is the alternate way to unlock BIOS passwords. But there's also ways you can boot with external tools that are usually Linux-based that will help you maybe crack those passwords. And that's where this comes in here, for example. This is like Kane, the Live CD DVD. We don't use this in our lab, but you can see if you boot the machine with this, you can see the drives, all the drives on the machine. Um, and there are tools built in here to help you, forensics tools, to try to get past those. And I think the last one to look at here is stenography. Stenography is probably the coolest. Um, it's hiding secret messages within things. An example is hiding a text message inside of a an image file, or and that text message could be a password to unlock another tool, another password protected file that was on the system. So of course there are some things that are become issues. Is just detecting them can be an issue. How you know the file itself has stenography or not. So look at the text file for this. Text, image, audio, and video all have different methods, and there are different tools for this. And there's actually a video, again, I mentioned before, in the, and actually it's one of my videos. It's a demo of using stenography, I think with an image file. So now, again, this chapter is going to have a lot more to it. The module summary here, you can see um, there are great tools, Privacy Erasers, QuickStego, things like that. You have RStudio Autopsy. Autopsy is fantastic, by the way, for a free tool. It's great. Um, so this tool will help you guide your way through finding files you need to extract, take to the next level. So it's possible you might find a encrypted file that was deleted in Autopsy. You extract it, or with some other file carver. Try to open it. And of course, it doesn't open. Maybe it has a file mismatch, extension mismatch. You change the extension from .jpeg to .doc. You try to open it where it says it's password protected. Then you need to crack it. So you can see you might have several layers, and if something's that hidden, or it's that hidden, maybe it's good evidence. So this is just a summary of some of the main points that again I wanted to make sure we looked at. Um, Encryption, program packers, data hiding, file structures, and so on. Review the chapter for all the contents and some overview of other tools that I did not show you here. And that is it for this review of anti-forensics techniques. Thank you for watching.